Algebra 1, Lesson 44, addition of rational expressions with equal denominators, addition of rational expressions with unequal denominators. So we're going to use our rules for adding fractions. So if we are adding fractions with equal denominators, all we have to do is add the numerators and then put the sum over one denominator. So what is this going to look like? Well, let's tighten. My camera's falling loose here. Hold on. There we go. So if we have the problem 4 over 2x squared plus y, and we're subtracting 6ax over the same denominator of 2x squared plus y, these are the same number, so I don't have to do anything there. All I have to do is just combine these. Now, are these like terms? No, they're not. So the only way I can simplify this is to just write 4 minus 6ax and then put it over one denominator of 2x squared plus y. It's that simple. That's all we have to do to solve, as long as we have the same denominator. I'll go ahead and do another example, but this example will have like terms. So let's say we have to add 5x plus 7 over 5a squared x, and then we're subtracting 3x minus 2 over 5a squared x. So again, we have the same denominator, and then we've actually now got polynomials in the numerators. And so we have to be careful, because with polynomials, if there's a negative here, we have to distribute this negative to each term in the second polynomial. So we'll distribute this negative, and that becomes negative 3, and that becomes plus 2. Now, when I combine these, they're all going to be written over one denominator, 5a squared x. But we have like terms here. I've got an x term, right? So I can combine 5x minus 3x. That's going to give me positive 2x, right? I can combine positive 7 and positive 2. That gives me positive 9. So our final answer, 2x plus 9 over 5a squared x. So as long as we have the same denominator, these problems are very easy. However, we do have to deal with them when they don't have the same, when they have different denominators. Our first example is pretty simple. We'll go into this a little slowly. We have 3/4 plus 2 over b. I have two fractions. They're not equal, or they don't have equal denominators, and one's got a letter in it, which is a little weird. So what's the common denominator of 4 and b? No, it's 4 times b. It's really simple. Whatever this denominator does not have, you multiply it by, and whatever this denominator does not have, we multiply it by. So this denominator will multiply by b over b for a value of 1, and this one will multiply by 4 over 4 for a value of 1. Now when I rewrite this after I multiply, I end up getting 3b plus 8 over the common denominator, which is going to be 4b. And that's my final answer. So I skipped one step here. If you need to see that step, what that is we end up getting 3b over 4b, and then we end up getting 8 over 4b. Once I've got these two fractions, they've got the same denominator, and then I can add them by writing them over 1. Not the number 1, but one denominator instead of 2. Now let's do a little bit of a harder example. Let's see if I can find the hardest one we've got. Let's see here. Yeah, this is the hardest example I've got. So we'll do 9 over xy cubed plus m minus 7ap over x y. Whoa, no, wait, that's not a hard one. That's easy. Hold on. I'm going to turn my paper and we'll scribble that one out. We'll do this one. X over m cubed plus 1 over c cubed plus a over m4. That's a A. All right, so here the common denominator is going to be the least common multiple actually here. So it's a good thing we learned that a couple lessons ago. Least common multiple of m cubed, c cubed, m4 is going to be the highest exponent of each, right? So the highest m is going to be m4. So our answer is going to have a denominator of m to the power of 4, and it's also going to have c cubed. Now, what is this first term missing to get m4 c cubed? Well, it's missing m c cubed. C cubed is missing m4. And m to the power of 4 is missing c cubed. So when we multiply this, we then get xm c cubed plus m to the power of 4 plus a c cubed. Now I see, now this is just the numerators, by the way. So that's this, this, and this. I didn't do any of the denominators because all the denominators are going to come out to m4 c cubed. Now, the reason why I only did the numerators is I need to check for like terms. Are there any like terms here that can be combined? No, there are not. So I can go ahead and write those over my numerator as the final answer. And that is it. If you have any questions, let me know on Moodle, and I will see you in class.